This is an update on the Allied AX190 communications receiver that I did a recent video on. I had a viewer that requested I do an alignment and show the process of aligning the receiver. This really doesn't need an alignment in my opinion, but I'm going to go through the actual alignment procedure in the manual that may help someone that is going through one of these adjustment of one of these radios. One thing to remember is alignment isn't a substitute for repair. Some people, will go into a receiver that's not operating properly and start turning coils hoping to improve the sensitivity and the selectivity of the radio, and that generally doesn't work. So you have to make sure you have a properly operating receiver before you attempt an alignment. Now, after I repaired this unit, which was a problem with the power supply, the unit came back to life and it appears to operate quite normally. I did find a few more problems with it, which turned out to be more bad solder joints. One thing I did also was I got rid of the incandescent bulbs and I added LEDs here, which I think was an improvement. Also, the S meter, which you could barely read now, is more readable. Here's the original 4 incandescent lamps that were in parallel across a 12-volt supply. What I did, I built a small circuit on this perf board, which just consists of a series resistor, a 1N4007 diode, 47 microfarad cap across that junction, and then 4 LEDs in series. Here's the circuit I used here. This point here just tied into the 12 volts AC that fed the original incandescent bulbs. This point here was the ground, and then this point is the 12 volts. This is AC in the green and yellow line, and then the red and black lines are the DC that feeds the LEDs. And this circuit uses quite a bit less current than the original incandescents. I think I measured about 18 milliamps through that series string of 4 LEDs. Here's some of the equipment I'll be using in this process to align this receiver. This is a Fluke 6062A signal generator. I've got a Boonton Model 91CA RF voltmeter. This is my dummy load, 8 ohm dummy load for testing amplifiers that I had in another one of my videos if you're interested. And then I have a analog voltmeter here, a FET voltmeter, Micronta 22-220A FET voltmeter. This RF voltmeter it's out of calibration. There's a calibration sticker. It was due in 10/10 of 1978, so obviously it's out of calibration. But when I connect, here's a 14.2 megahertz 30 millivolt signal. I'm measuring about just under maybe 24 millivolts, so I'm off about 6 millivolts. But I'm going to basically use this as a relative indication. I'm not that concerned about it. I have it terminated here, 50 ohms. So that will be the setup. This is a service manual for the AX190 and the SX190, which are basically the same circuitry, and the alignment instructions encompass 6 pages here in the back of the service manual. They actually have a couple different ways of doing this. If you use a sweep generator, which I don't think I'm going to use in this one. I have one, but I don't think it's necessary. It can be as simple as using the calibrator to align this thing, which isn't really, in my opinion, a really good way to do it. If you didn't have any test equipment, I guess it's a last resort. I'm just going to use the Fluke and some basic meters to do it. One thing that's really good to have is a calibrated signal generator that has calibrated attenuators, so you can actually adjust the output amplitude to a set amount. Here's one I used for years, and it's really a workhorse. It's a HP 8640B generator, and this is a nice one. It has calibrated attenuators. It has a digital readout on it. You can AM or FM modulate it, just the percent modulation and the deviation here. And I don't use this one much anymore. The newer generators are a lot better than these, but this is still a pretty good generator if you can pick one of these up. In most alignments, you basically start with the IF closest to the output. In this case, this is a dual conversion receiver. The second IF is a standard 455K CIF. And on the schematic you can see the output of mixer Q8. This is your IF chain right here. So the first step is going to be to adjust these transformers for maximum output. Now the nice thing about using a sweep generator is you can sweep plus or minus 455 kC to look at the bandpass of the actual IF amplifier. This is more important in FM radios where you have a wider bandwidth, and sometimes you'll have staggered tuned transformers. But in this case I think it'd be just fine to use a regular generator here. One thing you want to keep in mind through this procedure is keep your levels low enough so you don't activate the AGC system down here. If you start bringing your levels too high, the AGC circuit is going to start biasing down the level and you'll get erroneous readings. So that's one of the things you want to do here. In the past, a lot of times they would have you actually disable the AGC, but in this case I'm going to keep the levels low enough. It shouldn't be a problem. I'm injecting 2 millivolts into BC5. This is directly feeding into the base of Q8, which is in the VFO, which is this point right here. And I'm feeding it in on that side of Q8 because I don't want to load down the IF chain here. Right now I'm monitoring the AGC voltage. It says 0 and I've only got 20 millivolts, and I'm going to start bringing up the level. There's 3, and you can watch as the AGC voltage rises. I'm going to bring the volume down here. There's 15. There's 20 millivolts. So you can see the AGC is working. There's 136 millivolts. So I'm going to bring the voltage back down. And what I'm going to do is I'm going to feed as small a voltage as I can so I don't activate the AGC. And now I'm going to disconnect the speaker, and in its place I'm going to connect the dummy load. Now I'm bringing up the level of the RF. You can see the meter start to rise a little bit here, and I'm going to make sure my AGC voltage doesn't take off on me. The AF and the RF gain are at max, and I'm measuring a little less than 1.5 volts AC across the 8-ohm resistor. I'm going to use a sweep generator to adjust the IF. I'm using a WaveTech model 148A, and I'm sweeping between 452 and 458, and I'm applying the output to the base of Q8, which is right here, and I'm measuring at the cathode of the detector diode, which is right here. And according to the instructions in the alignment of the second IF, you tune MF1, T9, MF2, and T10 and T11 for peak symmetry on the scope. So here's MF1. Like I said, I believe this thing is pretty much aligned, but I'm going to vary it here. You can see there's MF1. Here's T9. Yeah, these are pretty much right on. I marked them before I adjusted them. Now you want to go back and adjust them again because there is some interaction between each stage. And here again, here's T9, MF2, MF1, T10, and T11. And this row on the IF board here. Looks like MF1 was off just a hair. The next step calls for adjusting the first IF variable amplifier. This is in the buffer amplifier, which is this stage here. Here's Q4, your first mixer, and here's your buffer amp here. And they call for adjusting L9, 10, 8, and 7. 7, 8, 9, and 10. Those controls are located in this shielded box here, and these have sealing wax on them, and I really have no reason to suspect they're out of alignment, so I'm not going to dig the wax out and make an attempt to adjust these. Like I said, the thing seems to be working okay up to there, so if you have one of these and it's out of adjustment, you can follow the instructions on page 5 of the alignment procedures. That would be here. I'm going to adjust the VFO alignment here. I've got a frequency counter connected to the VFO out jack on the back, which is here. Tune the main dial to 100 and adjust TC14 and the VFO box to 3.275 megahertz. And right now it's 3.278, pretty close. Here's the victim. TC14. It's not marked on the circuit. I had to go by what it's connected to. 3.275. Other way. Kind of touchy. This is one of those ones where you have to hold your breath while you're adjusting it. And this thing has been on for over half hour, so it's warmed up. I went past it again. I think that's as close as we're going to get. Tune the main dial to 450. It's about there. Adjust T7 to exactly 2925 on the frequency counter. It's 2926. Pretty close. T7 is this can here. And it looks like it's a hex. Okay, we're going to adjust T7 to 2925. And we're a little bit high. Waiting for the gate to close here. That's close enough. 292506. Repeat steps 2 through 5 as necessary to obtain a frequency of 2375 megahertz when the dial indicates 100 and the frequency of 2925 when it's 450. Okay, I'll do that off the camera. In other words, I'm going to go back over the same procedure again and make sure that they correspond. Okay, now I'm going to adjust the first crystal oscillator, or HFO. It says connect an RF VTVM and a frequency counter to HFO output J2 located on the rear side of the panel. And that is here. And I've got the frequency counter here and an RF voltmeter here. Set the band switch to 29.5 on the AX190. Locate T4 is in tune T4 on the RFPC board for a peak is indicated on the VTVM and also correct frequency 32.420 for the AX190, and we've got 3241, pretty close. Well, let's try, and use a ceramic tuning tool, because these are little ferrites and they'll break and ruin your day. When they crack, it's a terrible thing. Let's see. And that one was off a little bit. There's tune for maximum. Let's see what the frequency is. Okay, I got my old trusty Opto 8000. That B&K was giving me a little trouble. This one is really sensitive. So anyway, I've got T4 adjusted here in band 15. Low in here 17.920, which it is, and then I can go through each band and make sure that those crystal oscillators in the front end are on, and they look good here. And moving on, switch to 14, TC7 to 720. I did that to 7 megahertz. And adjust TC6 to 9220 to 9.920. That's pretty close. And I rotated through the band positions, and I made sure that they're within specs here for each band. It's for the AX190. So next will be the preselector and the RF amplifier. That'll be next. Number 5, preselector RF amplifier adjustment. I've adjusted all the controls, 14, 0, maximum. I've connected the speaker output to the dummy load and the meter up there. Adjust for 14 megahertz. Okay, I've got the band switch on 14 megahertz. I got the preselector on 14, 0 on the dial. And now I'm going to adjust L 4, 5, and 6 for maximum on the meter over here. And looks like that one is right on. And these are interactive, so you have to go back. Oh, this one's gaining a little. Okay, I'll go back and forth about 3 more times to get my maximum level there. L 4, 5, and 6 are these components here on the preselector. So that's what I'm adjusting. 4, 5, and 6 here. Okay, band switch to 27, pre-selector to 27, which it is, main dial to 500, which it is, adjust the signal generated at 27 megahertz. megahertz. Adjust TC 1, 2, and 3 on the 3 gangs pre-selector variable capacitor to maximum output. And that would be here. This one, this one. Whenever you adjust these compression mica type capacitors, you always want to adjust them so you're adjusting towards tightening, not loosening. So in other words, if you go above and below and bring it up from the low point, so you're actually tightening it when you hit the sweet spot. And that's what we want to do on all of those. Found something in the manual here that doesn't make a lot of sense. This is in step 5 on the pre-selector. It says rotate the band to 27, which it did. Pre-selector to 27, which it is. Then it says main dial to 500. Well, if you do that, you have no. If I set that to 2700, I get nothing. So I think the instructions where it says adjust the frequency to 27, they must have meant 27.5. So I'm going to go from there. So I'm going to connect the speaker output back to the dummy load and the meter here, and then adjust for maximum. So with it adjusted to 27.5 megahertz, I adjust TC 1, 2, and 3 for maximum output here on the meter, which I will do. Oh, they were pretty close. Well, that one is off a little. Like I say, this thing is pretty darn on the spot here. Ooh, that one's way off. I'm going to go back. And I do this back and forth. I'll do it a couple more times till I'm maxed them out there. So that completes that step. Step 9, adjust the frequency of the generator to 3.5, which I did. Band switch to 3.5, pre-selector to 3.5, and main tuning dial to 0, which is preset. Adjust T1, 2, and 3 for maximum output. T1, T2, and T3. That one's off just a hair. Pretty close. That one was right on. Every time I adjust these little powdered cores here, it makes me nervous. I think that's about maximum for that one. Repeat steps 3 through 10 until no interaction is obtained and all transformers and trimmers are tuned for maximum output. I'll do that and then I'll be back. Okay, they want us to adjust the crystal calibrator. I've adjusted these. Connect speakers, speakers connected, antennas connected, main dial to 1500. Push the 100 kc calibrator. Well, signal isn't real strong today. I've just got this on a long wire outside. Press the 100 calibrator. Listen for a beat sound. I just TC17 for 0 beat. And that's this one. I can just barely hear. Now let's see if it signal comes in a little stronger. Oh boy. Sounds like a dog in pain. That's pretty much 0 beat. Number 7 here, reject and select alignment on the Q multiplier. RF gain full clockwise, AF gain full counterclockwise, function on AM. And let's see, receive one of the calibration signals. Q multiplier to reject. Tune knob to center. Adjust VR15 for a minimum reading on the S meter. And that's about as minimum as it can get, so I'm not going to touch it. VR15 is right down here. Q multiplier to select position. Adjust RF gain control to indicate S3 or S4. There it is right there. Adjust VR16 to maximum reading on the S meter, but no oscillation when rotating the tuning knob. I'm going to leave it right there. If it's not broken, don't break it and don't adjust. Okay. Number 8. Lower sideband and upper sideband crystal oscillator. RF gain full clockwise. AF gain for desired audio. Band switch any band. Pre-selector. Adjust to the selected band. We'll use 14 megahertz, I guess. Q multiplier off. Push the 100 kilohertz knob. Set to receive one of the calibration signals. USB or LSB. Connect it speaker to the speaker jack. Tune lower core of T12 to get a beat sound. Here's T12 right here. And we've got an upper and a lower section. And I don't know if I have the proper tool here. Yeah, I can get both cores. Section 9, trap coils L1, 2, and 3. Here we're going to adjust, well, on the schematic, here you can see L1, 2, and 3. This is a series tune, parallel tune. Here's a parallel tune. This helps with rejecting images and other signals we don't want. So I set the controls 3.5 megahertz. Pre-selector 3.5, main dial 0, function AM. And we want our audio connected to our dummy load and our meter there. Well, this happens a lot here. On step 6 here, adjust L3 to 3 dB decrease point on the VTM. Unfortunately, L3 has a cracked core, so I can't adjust it. So hopefully that's going to be alright. That's a problem, you know. If someone has been in here with a metal tool and they've tried to adjust, this is the only one I found that was broken. Never adjust these cores with a metal tool. They'll break every time. And if you try to adjust them and they don't move, don't force it, because it'll crack. There's little things you can do. You can heat them up. You know, I clean the wax out of these. So I'm wondering if that wasn't done at the factory, because this had wax in it. And I cleaned the wax out of all of these. That's the only one that was cracked. Okay, I've got the radio connected to an outside wire. Already I can hear signals are coming in stronger. This is 20 meters. Okay, I'm going to check the dial accuracy here. I've got it tuned to 14.2 megahertz. It's 14.2. Let's go to 14.4. It's looking good there too. Let's try 7 megahertz. Go down to 7.1 megahertz. Whoops, wrong generator. 7.1 megahertz. And adjust the pre-selector here. That looks pretty good. 7.1. We can adjust this, it's got a clutch in it here. You can adjust if I do it with one hand. Let's try 7.35 megahertz. Looks pretty good. How about 21, try 21.2, frequency 21.2 megahertz. Well, looks pretty good. I'll test the rest of them there, but it looks like the tracking is pretty good here too. I'm not going to mess around with this much more. Like I say, I'm not going to probably use this rig that much, but it's kind of nice to play with. This one wasn't in too bad a shape, other than had a power supply problem. Only bad thing is we got a couple broken cores here. That's not good. But it could have been worse. There's a lot of places in here where you can really mess things up. There's other ways to adjust this too. Just like in the old Heath receivers, they used to have it where you could actually do an alignment using a calibrator. But if you got the test equipment, that's a better way to do it. I'd like to get an SX190, the shortwave version of it. I think that would be kind of nice. They're pretty similar, but I listen to shortwave more than I do the ham bands anymore anyway. Well, this video is starting to get long, so I'm going to wrap it up. Anyway, the Allied AX190. Nice receiver. Came out in early 1970s. And with a little TLC, they should last a long time. If you get one of these, check the solder joints in them. I found a lot of bad ones in this one. Anyway, I hope you enjoyed it, got something out of it. Thanks for watching, and we'll catch you in the next one. Bye for now.